There are many useful ways to combine different images. A typical goal is to define regions of interest so an evaluation task can be restricted to certain areas in an image. Typically, binary masks are used, where white foreground areas indicate the region to evaluate. Black background areas indicate the regions that are ignored. Such masks can be created in many ways, for example, manually painting over the regions or using interactive threshold selection, or automatically by standard algorithms like Otsu's method, or even via advanced machine learning models. In all cases, basic logical operations can be useful to then combine multiple such masks to get all the different desired regions of interest. Many such logical combination tasks can be used in ExamFlow. The intersection of two objects A and B can be found using the logical AND task. The union of two objects can be found using the logical OR task. A bit less frequently used is the exclusion task, logical XOR. Maybe in practice the most useful of them all is the complement task, logical and not. Here is an example where we start with a grayscale image, then interactively define a binary mask based on the intensity values above or below a selected threshold. We can then use tasks to fill all the cavities or extract the largest component. Or we can define quadrants and, for example, keep only the top left quadrant and use that to mask out the part of the original grayscale image. Using the right combination of logical operation tasks, we can now derive other useful masks, like here, for example, the inner region. In this first example with two circles, we see the different ways to combine these input regions. Logical invert only takes one input image and changes white to black and black to white. Logical AND takes two inputs, A and B, and creates a mask that contains the parts that are both in A and in B. Logical OR contains any parts that are in A or in B. Logical exclusive OR keeps the parts that are only in A or only in B, but not in both parts. Logical AND NOT keeps the parts that are in A and not in B. Instead of a circle, of course, any other shape or complex mask can be used. Here, a checkerboard pattern replaces the second circle. And again, you get the resulting intersection, union, exclusion, and complement. Instead of abstract shapes, we can now test these operations on masks derived from the grayscale image earlier. For example, here, the A is the thresholding result, and B is the top left quadrant mask. Logical AND here is a typical case where we restrict the evaluation region similar to masking. Logical AND NOT could be used to create the other part of the puzzle. Another example is using the inner region as input B. Logical AND can then again restrict an evaluation to these inner structures. Logical OR would fill up the inner region. Logical AND NOT would remove the inner structures. A final interesting case here is using the outer region as A and the thresholding result as B. Then, for example, logical AND NOT can be used to get the holes in that outer region. More advanced cases can use a task to combine multiple images and also use arbitrary formulas. For example, the logical AND can be written using mathematical operators. Complex formulas can then also combine multiple inputs at once. Another advanced scenario is combining multiple binary objects like A and B and C here into one multi-valued image. The combine task here takes multiple inputs and overlays them into a composite image. If you have any questions, leave a comment below.